So I'm here to present on a study that we actually started in 2003, and it was presented at the NDOT in, I think, Colorado. Can't even remember, it was quite a while ago. So we have used the same data sets, and what we're doing now is we're finalizing the data analysis and the discussions. And we found that the analyses that we did so long ago have still not been touched on in the research today, so they're very much relevant. So the rationales and objectives were to target Elk-vehicle collisions, and this is because in the Western ecosystems, in the central Canadian Rocky Mountains, elk is a dominant species in the community, and 27% of all wildlife-related accidents were with elk. And if you zero in Banff National Park, elk were the dominant species being involved in collisions prior to when mitigation wildlife overpasses and underpasses went in. So we want to look at the distinct spatial and temporal patterns for these elk-vehicle collisions. But we want to use demographic data that was available to compare between the collisions and the adjacent populations. And then we want to tease apart the covariates of traffic volume and population abundance on the occurrence of elk-vehicle collisions and apply this to mitigation planning. So the study area is the Central Canadian Rocky Mountains, which includes Yoho, Banff, Kananaskis, Kootenay, and then we zero in on the Kootenay region and the Banff region where we have elk and where there was no mitigation at the time of this analysis. And also there was demographic data available for these two areas, so we could do the comparisons that I talked about. So in Banff, we focused on phases 3A and 3B, and this was prior to mitigation for the data sets. Now there's mitigation on both those sections, but so there was no fencing and crossing structures. And the data set, I'm not sure if I put the date on here. I'm pretty sure it's about 1980. I think I have it on the next slide. I'll wait for that. Yeah, here it is. I just can't see it quite. 1986 to 1996. And there was 812 EVCs that we looked at in the Central Canadian Rocky Mountains. Within this data set, we had the age of the elk, and we had the sex of the elk, and we also had percent marrow fat content for the carcasses. So it was a pretty good data set. And then we had the elk relative abundance data sets from the Parks Canada and Kootenay National Park and Banff National Park. And they had done ground counts in spring and fall in 1986 to 1996. So these time periods were comparable. And then we had annual average daily traffic volumes for the highways. So for each mini analysis, we'll go through the hypothesis, methods, results, and discussions. So for the first mini analysis, we looked at are younger elk being killed on highways more than adult elk because of less experience and things like that. So we divided the data set in between sub-adults, which was less than 2 years, and adults, which are greater than 2 years old. And we looked at the total number of adult elk occurrences. Sorry, now I'm onto the results here. So we compared those two, and we found that the total number of adult EVC occurrences were higher than sub-adult. And that was simply because there are more adults in the population. So you would see more adult collisions. And that was in the broader study area of the Central Canadian Rocky Mountains. But if you compare it to the adjacent population numbers, now zooming in on Banff and Kootenay, you would find more sub-adult elk are more prone to being involved in collisions than adults, as expected, more than expected from the adjacent population numbers. And so the reasoning for this may be that Sub-adults are more prone because they have less experience. Female cows, when their calves are traveling with the cows, they're distracted during the mating season. Calves often follow females across roads. The cows are go across the road faster, and the calves are more hesitant, so they may be involved with the collision. If a motorist swerves for the cow, she may indeed hit the calf. So the next mini analysis was to look at sex. So looking at the broader study area, we found that there were more adult females than males. And this is to be expected because there are more females in the population. If one was just to look at that data set only, they would say more females are getting killed on the roads. But are females more prone than males on getting killed on roads? And if you look at the adjacent population, that isn't so. Males are more prone to being involved in elk-vehicle collisions. So this is because, again, we'll show in the discussion, but this result did not come through for sub-adults. This was within adults only. So this comes through. We've read a lot in the literature about male elk being involved in the wreck in the fall season, so they're more distracted. They may get hit during that time. We'll go into seasonal details coming up. But also more elk, the male elk might be moving further distances in their home range and when their migrations and for foraging. So these are the things that could make male elk more prone to collisions. So then we looked at the fat marrow content in the carcasses, and we looked at whether there was a difference between elk being killed on highways and railways in Banff as opposed to the fat content of the predators. And we found that, let me read this, percent marrow fat content of highway and railway killed elk was not significantly different, so that was the same, but both the transportation collisions had greater percent fat content than predator killed elk. So we're about to discuss this more fully. We have to read the literature on that one. So there is no discussion slide for that one. Then the next one, mini analysis, is season. And we want to know what season. We had 4 seasons when they were being involved in collisions most often. And not surprisingly, we found that more collisions were occurring in the fall. And in the fall, it was more so for males, which then supports our previous result that showed more males are killed on, or more prone to being killed on the highways. And these males are probably more prone to being killed in the fall. So we can narrow that down. And sub-adults to adult EVCs in the fall was 300% greater than in the spring. So that is saying, that's just a graph showing that result. So the males, you can see the clear bars, September, October, November are the high months of when the males are more prone to being killed on highways than the females. And you can see the seasonal mean, it's above the seasonal mean, and this was done with an ANOVA, and that's how we got our significance. So more EVCs occur in the fall. When compared to the population, more males than females are being killed in the fall. When compared to the population, more sub-adults and adults are being killed in the fall. So what is this saying? That in the fall, there is a addition of the spring cohort coming in, which means that there's higher numbers of elk and fewer numbers in the spring due to harsh winter months and the elk that perish during the winter. So in the fall, we just have higher numbers. So that makes sense that we're having the ones that are more prone, the sub-adults and the males in the fall, because of things like the rut and what we've always said. But there's other reasons too, and abundance is a big one, and that recruitment of the young calves coming in are inexperienced. putting it all together there. So then we want to look at traffic volume and abundance. And these relationships can be complicated without being able to tease one apart from the other. So that was our goal because we had the data to be able to do something like this. So traffic volumes, we did a t-test to compare traffic volumes in the spring and the fall in the Bow Valley in Banff, and they're not significantly different. So if we compare the spring and the fall, elk abundance counts and elk collisions, we can control for traffic volume. Traffic volume is not impacting the number of collisions. So when we look at that, we can see EVCs, elk vehicle collisions, increased at a greater rate during the fall season when elk abundance numbers were significantly higher. So again, that's calf recruitment coming in. The numbers are higher. You can see the top black line showing higher elk abundance counts in the fall with the squares, and spring staying almost the same, the collisions, and then they increase in the fall. Next slide. So we want to look at traffic volume. So traffic volume, as traffic volume increases, we expect to have more elk vehicle collisions because they have less time to safely cross the road. But this can be confounded by the fact that some species, some animals avoid roads when the traffic volume gets to a specific threshold. And we've seen this in Arizona, the research by Gagnon and Dodd that have shown this in detail. So EVCs, I'm sorry, I have a hard time. I'm going to look at my other computer here because there's some of that information, that text has been covered up. There we go. So EVCs on each road type were highly correlated to traffic volume. So this is looking at the Central Canadian Rocky Mountains, broader region. We looked at Kananaskis, Trans-Canada Highway in Kananaskis, and we looked at the Trans-Canada Highway in Banff, 93 South in Kootenay, and Yoho, Trans-Canada Highway, and they all had different traffic volumes, and the highest was in Banff, and the most collisions occurred when the traffic volume was the highest, and it was a 100% correlation with traffic volume. So we know that EVCs increase with traffic volume. We don't know, but we know that they're increasing, or that they should, and that's what we know in the literature. But as traffic volumes increased, so did the EVCs on each road. Okay, we know that. However, a different relationship was found when comparing Kootenay to Banff National Park, that zoomed in region. So here we found as traffic volume increases by 22% over the time period, that EVCs decreased by 89% and 83% respectively in TCH Banff and on Highway 93 respectively. So we can see here that this is a relationship that we might not expect. As traffic volumes increase, elk numbers are decreasing, elk vehicle collisions are decreasing, but so is the number of elk per kilometer, because we have those ground counts to compare it to. So we know that there is something else driving this other than traffic volume, and that would be the abundance. And then when we did our ANCOVAs, we found indeed that, go to my other computer here, indeed as number of elk per kilometer increased, the number of EVCs increased. So abundance is definitely driving this relationship. And we found for traffic volume, as traffic volume increased, EVCs decreased. So it was an opposite relationship, but it was not as strong as the abundance driving this relationship. Okay, so the next screen here. So the relationships between abundance, traffic volume can differ by, and roadkill can differ by species. It can differ over time, and it can differ by abundance, and also by an animal's, I guess, threshold of road avoidance to cross a road. So of course by road type. So these things are important, and that's why, and you'll see in the next couple slides, we'll talk about looking at long-term data sets and why this is important for mitigation planning. Okay. So we investigated, and we are investigating right now, why elk abundance had decreased in Kootenay National Park and in Banff National Park. And that's because wolves recolonized the park in the 1980s. So this is what we're seeing now. Biased traffic collisions with calves would reduce recruitment for the population. That could also be an impact. As we saw, more calves are susceptible to roadkill, and we could have less of recruitment. But now, of course, we've got mitigation measures in place in Banff and in Kootenay. So this relationship, if we looked 10 years post 1996, we could indeed find something very different. So by looking at these long-term data sets of abundance, traffic volume, and elk-vehicle collisions, we can figure out perhaps when the species within that ecosystem is declining to a level that is not acceptable or sustainable, and that's when we put in mitigation measures. If we know traffic volumes are going up and the animal counts are going down, then we know that something is happening here, whether or not there's elk avoidance or just the numbers of that population have been depleted to maybe by roadkill or by avoidance, both happening at different times, and it's been depleted, and that's when we want to put in mitigation. The trick is to have enough data to know when that depletion is occurring. Quite often we put mitigation at hotspots where we see an increase in collisions occurring. But perhaps if you see a decrease in collisions occurring, then mitigation is also warranted because we want to do recovery efforts. And this would be really something that we need to look at here in Ontario with turtles, for example. So I think a big thing that came out of this is by looking at the demographic data, we make different conclusions. Instead of saying more female elk are involved in collisions, we can say females are being killed more often, but males are more prone to collisions. So we can look at that from a population perspective, and same with the sub-adult relationship. And we can target our campaigns towards these results. So we all know fall is a big one. You see it all over the news reports every day for the OPP to Ontario Provincial Police to tell people to slow down in the fall while all the animals are getting ready for winter and things like that. So we know that, but we don't know necessarily that it was the young being more prone to collisions. So in places like Ottawa, where we have a very high deer vehicle collision rates, we have campaigns that are consistent and targeted, and they can be targeted in the fall. And they can also say, if you see a calf or a cow, there's always one going to be following. So be careful with that kind of circumstance. So with that, I'm going to sign off and take some questions. And I wanted to, while I have the microphone, thank you for the opportunity to present these results, because without this, I don't know if this paper would ever have made it out to the public. Female moose protect young from bears by spending more time next to roads. Female moose protect young from bears by spending more time next to roads. Is this true for elk and Banff? I'm not sure. And maybe Trevor Kinley, maybe he could chime in on that.
Yeah, I don't have any specific information about that, but certainly anecdotally, we see that across a number of species, that they seem to be hanging out on roads for no particular reason, and other than it seem to protect them from predation risk. Anecdotally, female grizzlies with cubs that are susceptible to cannibalism by grizzly boars seem to keep coming into the highway corridor, into the fencing, more than males do. So there's some anecdotal evidence, but I don't know if it's true across species or to a great extent.
What is the specific traffic volume? Did you consider the diurnal change in traffic volume and potential crossing times of elk? Okay, so the specific traffic volumes, they range, and I'll have to look that up, but they range from anywhere, I think 5,000 to 15,000 on those highways, on the broad study area. And the diurnal change in traffic volume, no, we didn't go into that detail. We could, definitely, because we have the data. What we find for ungulates, generally speaking, are dusk and dawn for diurnal hotspots with collisions, and that's in the literature, and it would be interesting to see if the same happens with elk in this area.